Hello everyone. In this session, I'm going to talk about lipid transport and lipoprotein metabolism. You know that you take lipids from your diet, and dietary lipids are composed of triacylglycerols, phospholipids, and cholesterol ester. The most predominant lipid in the diet is triacylglycerol. And all of these lipids are hydrolyzed by specific enzymes in the digestive tract, in the gut. For example, triacylglycerol is digested by lipase enzymes, and they are degraded. They are degraded in the intestine, and phospholipids are also degraded by phospholipase enzymes, and cholesterol ester is metabolized by cholesterol esterase. Of course, there are some other esterase enzymes that are not very specific, and they can act on any lipid that come into our digestive tract. For digestion of triacylglycerols, which are the most predominant lipids in our diet, we have lipase enzymes, and there are three different types of lipase. One is lingual, which can be found in the mouth, and then we have the gastric lipase, which is found in the stomach, and we have the pancreatic lipase, which is secreted from pancreas into the intestine, into the small intestine. Pancreatic lipase needs two partners to be completely active. One is called colipase, as it cooperates with lipase. These two proteins are both secreted from pancreas. And then we have the bile acids. And you know that bile acids make the lipids more soluble for us. They make the lipids in micelle form, and then they makes them available for the pancreatic lipase to work on. But at the same time, bile acids exert an inhibitory action on pancreatic lipase. Therefore, colipase should be present so that pancreatic lipase can work efficiently. This is a micelle, and you can see that bile acids make the micelles from triacylglycerol, and lipase can act on these micelles, but colipase should be present to give complete access to lipase. The function of pancreatic lipase is to separate the fatty acids from the glycerol that is found in the triacylglycerol molecule. We may have in the small intestine, we have some triacylglycerol and some amount of diacylglycerol, and diacylglycerol is provided by the function of gastric and lingual lipase enzymes. When you eat the triacylglycerol, they pass through the mouth and the stomach, and the triacylglycerol molecules can be degraded by these two lipase enzymes, but they are not very efficient, and so they can provide us with some diacylglycerol and not more. So the most efficient lipase enzyme is pancreatic lipase, and it can cleave the bond between the fatty acid and the glycerol, the first bond and the third bond. And so pancreatic lipase is not able to separate the middle fatty acid on carbon number 2, so it can only separate the fatty acid from carbon number 1 and carbon number 3. So at the end, the product of the pancreatic lipase is free fatty acids plus monoacylglycerol, because this one fatty acid cannot be separated from glycerol. And this monoacylglycerol can be absorbed in the small intestine as it is but it can also be more degraded to glycerol and fatty acids by the function of non-specific esterases that are present in the small intestine, as I mentioned previously. About 25%, 22 to 25% of monoacylglycerol will be completely degraded to glycerol and fatty acid, but about 75% of it will be absorbed as it is in the form of monoacylglycerol. Now, this is an intestinal epithelium cell, and here we have the intestinal lumen, and you know that the lipids are absorbed and they are transported mostly in the lymph, and some amount also will be transported via the portal vein. Monoacylglycerols that I mentioned are the most predominant form of lipids that are absorbed in the small intestine. And fatty acids, they enter the intestinal epithelial cell, and there they are again combined together and make up triacylglycerol again. So but you degrade triacylglycerol in the intestinal lumen, but after they are absorbed in the intersite, in the intestinal cell, they are again joined together and make up the triacylglycerol. And then this is the triacylglycerols that are packaged into the form of lipoproteins and are transported into the lymph. Of course, from the lymph they will join the blood circulation and are continue their metabolism there. The free glycerol that is formed in the intestinal lumen also enters the intestinal epithelial cell, but they do not enter the lymph, but they are absorbed into the portal vein, and so they are delivered directly to the liver where they are metabolized. About 22% of the glycerol is absorbed as free, but more than 75% is absorbed as in the form of monoacylglycerol. Cholesterol is also absorbed from the lumen of the intestine into the intestinal cell. And cholesterol is found in our diet, and we also take some amount of phytoesterols, which are the esterol or cholesterol counterparts in the vegetables, and they are different from cholesterol, but they are also absorbed into the intestinal cell to a little less amount compared to cholesterol. Cholesterol is absorbed more efficiently compared to phytoesterols, but phytoesterols that are plant esterols are also absorbed by the same mechanism. There is a transporter in the apical membrane of the intestinal cell called NPC1L1 that is responsible for the absorption of cholesterol and also phytoesterols into the intestinal cell. And there they can be converted to cholesterol ester. It means that the one fatty acid can be attached to the cholesterol, and cholesterol is formed. Cholesterol ester is formed that is absorbed into the lymph after being packaged into lipoproteins. Both cholesterol and phytoesterols are esterified, but again here cholesterol esterification is more efficient compared to phytoesterols. And the esterification of cholesterol is performed by an enzyme called acyl coenzyme A cholesterol acyl transferase, and as its name implies, it transfers an acyl group, it means a fatty acid, from acyl coenzyme A into the cholesterol. And any cholesterol that remains free in the cell and is not esterified is pushed back into the lumen and so it is transferred out of the cell, and it is excreted from the intestinal cell, and it is at last it is excreted in the feces. So free cholesterol will not remain into the intestinal cell, but it is moved outside by two transporters called ABCG8 and ABCG5. These are the transporters of free cholesterol from intestine out of the intestinal cell into the lumen. So cholesterol have two fates when it enters the intestinal cell. It can either be esterified and absorbed, or it can remain free and moved back into the lumen. Here you can see the function of ACAT enzyme that I mentioned in the previous slide, that acyl coenzyme A cholesterol acetyltransferase. This is the free cholesterol, and you know that from your previous courses that cholesterol in its free form has a NO-H group, a hydroxyl group here on its ring, and that can be esterified. It can accept fatty acids, so fatty acids can bind here to this hydroxyl group, and this fatty acid is taken from acyl coenzyme A. That is why the enzyme is called acyl coenzyme A cholesterol acetyltransferase, because it takes the acyl, the fatty acid, from acyl coenzyme A. So the acyl coenzyme A loses its coenzyme A and is bound here to this hydroxyl group. So this is intercellular esterification of cholesterol, and what is made is cholesterol ester. So here we have the free cholesterol, and here we have the cholesterol ester. When the cholesterol enters the intestinal cell, it should be esterified by this enzyme to cholesterol ester so that it can be absorbed. Of course, we absorb some amount of free cholesterol, but most of the free cholesterol will be excreted back into the lumen. First fatty acid and the glycerol, and phospholipase A2 cleaves the bond between the second fatty acid and the glycerol. And we also have phospholipase C that cleaves the bond between the phosphate and the glycerol, and phospholipase D that cleaves the bond between the alcohol and the phospholipid. So you can see for different bonds in the phospholipid molecule, we have different phospholipase enzymes. The most important phospholipase enzyme that is found in the intestine is phospholipase A2. It is also secreted by pancreas into the intestinal lumen, and it first is made and secreted as prophospholipase A2, and then it is activated to phospholipase A2. So it is first made as a proenzyme, and then is activated by the protease enzymes to phospholipase A2. The most important enzyme for the activation of phospholipase enzyme is trypsin, that is also secreted by pancreas. Okay, as I mentioned, when we want to absorb lipids, we package them into some particles that are named lipoproteins. So we have to know the structure and form of and different forms of lipoproteins to be able to understand the basic concept of the digestion and absorption of lipids. Here you can see the structure of lipoprotein. As you can see, they are shaped as a ball, and they have an inner layer, an inner core, and an outer layer. Here they can see the inner core, that it consists of triacylglycerols and cholesterol esters, and they are hydrophobic lipids. But there is an outer layer that consists of free cholesterol, and also mostly from phospholipids. And this circular structure also contains proteins named as apolipoproteins, and there are different types of proteins that take part in the structure of a lipoprotein. You can see that some of the proteins are very large, and they capture all they surround the whole structure of lipoprotein, but some proteins are smaller and they just attach to a very local part of the lipoprotein. Again, here you can see the structure, schematic representation of the structure of lipoprotein, and the core of the lipids here that consists mostly of the triacylglycerols and cholesterol esters is evident here. And remember that these triacylglycerol and cholesterol ester molecules are completely hydrophobic. So the completely hydrophobic molecules make the core, but amphipoetic molecules such as free cholesterol and the phospholipids form a monolayer here, from an outer layer. And again, we have the proteins here. For example, it is ApoB100. These are called apolipoprotein proteins, and so they are named as ApoB, for example, ApoC, ApoE, and etc. We have different types of lipoproteins based on their density, and the biggest one with least density is called chylomicron. It is made in the intestinal cell from dietary lipids. And then we have the VLDL, which is smaller than chylomicron, but is still bigger than other lipoproteins. And VLDL is taken from very low density lipoprotein. So it has the again low density compared to other lower density compared to other lipoproteins. And then we have the IDL, intermediate density lipoprotein, LDL, which is low density lipoprotein, and HDL, which is high density lipoprotein. Chylomicron, as I mentioned, is made from the dietary lipids, so it contains mostly triacylglycerol. For its lipoproteins, it contains ApoB48. It is the biggest protein in the chylomicron structure, and we also have two other smaller apoproteins, including ApoE and ApoC2. We will see what the function of these apolipoproteins is. VLDL also contains lipids, and at the same time it contains apolipoproteins. The most important one and the biggest one in the structure of VLDL is ApoB100, but it also contains ApoE and ApoC2. Then we have the IDL. It contains, again, similar to VLDL, it contains ApoB100 and also ApoE. And we also have LDL. It mostly contains ApoB100 as its most predominant apolipoprotein. It doesn't contain any ApoC2 and ApoE. And at last, we have the HDL, high density lipoprotein. As its name implies, it has the highest density among the other lipoproteins, and its apolipoprotein is the most important one. It contains many proteins. HDL is rich of proteins, but the most important one and the most predominant one is ApoA. Again, we have different ApoA lipoproteins, apolipoproteins. First, when the HDL is synthesized, it is in the form of a disc, like an empty ball, and it is called nascent HDL. Nascent means newly made, and then after it is circulated in the blood and through the metabolism of cholesterol, it absorbs cholesterol and it esterifies and transfers the cholesterol into its core, and then it takes this spherical form, and like it is like a ball shaped, and when it is full of cholesterol. So this is nascent HDL, and this is the mature HDL. Lipoproteins can be separated in the laboratory. They can be separated by ultracentrifugation or by electrophoresis. If you centrifuge the mixture of lipoproteins in the blood by ultracentrifuge, they are separated based on their density. So the one that has the lowest density of all will remain on top, but the one that has the highest density will travel all around, all the way, and sinks to the bottom of the test tube. So the lipoproteins will be separated by this order. At the top, you have the chylomicrons that have the lowest density, and then you have the very low density lipoproteins, and then LDL or low density lipoproteins, and at last high density lipoproteins or HDL that has the highest density, so it sinks down. If you separate the lipoproteins by electrophoresis, since electrophoresis separates the particles based both on their size and their electric charge, so the order of the separation will be as first chylomicrons, then LDL, and after that VLDL, and at the end we have the HDL. LDL is called beta lipoproteins, VLDL is called pre-beta lipoproteins, and HDL is called alpha lipoprotein. Currently in the labs, if you want to separate the lipoproteins, you have to do electrophoresis because it is more, it is easier. It is less time consuming, but ultracentrifugation is very difficult. It needs some expertise, and at the same time, it is very time consuming procedure. Okay, here you can see the intestinal cell, and here the intestinal lumen. So the lipids are absorbed from intestinal lumen into the intestinal cell, and there they should be packaged by proteins to make lipoprotein. Proteins are synthesized in the rough endoplasmic reticulum, and then they are transported into the Golgi apparatus, and then they are secreted out into the lymph vessel. In the soft endoplasmic reticulum and in the Golgi apparatus, the lipids are mixed with proteins, and they are packaged into the chylomicrons. So they enter lymph vessel after they are mature.